class. Now, next what we're going to talk about, we're going to start talking about acid bases. And this is my favorite part to talk about. If you remember, back in Chem 1A, which seems so long ago now, we taught you that if you have an acid, it's going to start with H. And if you have a base, it's going to end with OH. We said every time you see a compound starts with H, that's going to be your acid. Ends with OH, that's going to be your base, right? Acid is going to start with H, and then a non-metal after that, like HCl, HBr, HI, and then base is going to end with OH, and it's going to have a metal, and then an OH. NaOH, KOH, lithium hydroxide. Okay, now that was great, but that was so Chem 1A. We want to get fancier now. So again, in Chem 1A, we taught you if you have an acid, it's going to start with H. If you have a base, it's going to end with OH. And that was so months ago. Now what we want to do, we want to expand our definition of what's an acid and what's a base. So we want to expand the definition of what does it mean to be an acid and what does it mean to be a base. Now there are different ones. There's the Arrhenius definition, and what that one says is that acid is going to increase the concentration of H plus in water, and for base is going to increase the concentration of OH minus in water. There's Bronson and Laurie definition, which says acid is going to donate an H plus, and base is going to get that H plus. And usually H plus, the other name for it is proton. Now Lewis definition, which is they usually use it in organic chemistry, it says acid is going to accept an electron pair and base is going to donate an electron pair. So far so good. Now the one that we are going to focus on is this one right here. And you are going to repeat after me right now. Acid is going to donate an H plus, base is going to get an H plus. Acid is going to donate an H plus, base is going to get an H plus. I need you to remember that, because if you remember the basic, as we get more complicated, it's not going to be that bad. So what is the acid going to do? Acid is going to donate an H plus. What is the base going to do? Base is going to get the H plus. Okay, so far so good. Now, there's one more thing I want to mention now. So acid is going to donate H plus and base is going to get the H plus. Now here's the thing, think about it this way. If you want to go and adopt some puppies, you need to be able to afford it, right? You need to have the money to go and adopt the puppies, because you have to feed the puppies, you have to do other stuff. So you need to be able to afford it before you can go and get those puppies. Now this is exactly the same thing. Before base goes and get the H plus from the acid, base needs to be able to afford it. So you are a base if you have somehow you have extra electron. So what's a base? Usually you have a base if you have lone pair, you have a minus charge, you have extra electron, because with the extra electron, you're going to be able to afford getting an H plus. So make a note of that. So acid needs to donate the H plus. Now base needs to accept it. So what does it mean to be a base? To be a base, to be able to accept the H plus, you have to have extra electron, right? Because the electrons are like money in the world, right? If you have extra electron, you have lone pair, you'll be able to afford the H plus. We're good so far? Okay. So again, we're gonna get a little bit fancier than just H and then OH. Now let's talk about H2O for a second. Let's talk about H2O. What do you think H2O is? Is H2O an acid or is H2O a base? What do you think? So the question is H2O an acid or is it a base? What do you think? Now here's what I want you to think about. Think about Chem 1A actually. So the question is, what is H2O? Is it an acid or is it a base? If you remember from Chem 1A, how did we form an H2O? When we did a double replacement reaction, we said H plus OH minus, don't say HOH, and it gives you H2O, right? H plus OH1, it gives you H2O. So what's the base? What's the water? Is it a base or is it an acid? What do you think? Now, water has H plus, it's an acid, has OH minus, it's a base. So what is water? Water is an acid and is a base. Water can act as both. So water can act like an acid, it can also act like a base. What we call that, we call it amphoteric. So we said water is amphoteric. What does that mean? That means it can act as an acid or it could act as a base depending on the situation. So water is amphoteric. It could act like an acid or it could act like a base depending on the situation. And you're probably going to ask me, what does that mean depending on the situation? I will show you in a second. Alright, so let's get to it and see what does it mean depending on the situation is going to act like an acid or base. Let's write down HCl plus H2O. Okay? HCl plus H2O. Hydrochloric acid is my acid. Okay? So hydrochloric acid, that's going to be my acid. And what did we say? Acid is going to donate an H plus. Acid is going to lose an H plus. Now, because hydrochloric acid is my acid, then water is going to act like a base. Okay? So again, water could act like an acid or base depending on the situation. Here I have HCl plus water. Since HCl is my acid, water is going to act like a base. Okay? Now, what does it mean to be acid? Acid is going to lose H plus. What is the base is going to do? Base is going to get the H plus. Okay, I need you to remember this right now. Acid is going to lose H plus, base is going to get H plus. You remember that? We're solid. Okay. Now, what does that mean? Let's see how that works. So, hydrochloric acid is going to lose an H plus. If it loses an H plus, it becomes Cl minus. Now, water is a base, is going to get an H plus. If it gets an H plus, it's going to become H3O plus. Okay. Now, what I want to do actually, I want to show you the mechanism for this. You don't really have to know this for this class, but sometimes when you know how things happen, it actually helps you to understand them more. So I have hydrochloric acid, like an ionic compound. I have an H plus and Cl minus, and H2O is a covalent compound. For covalent compound, we had Lewis structures. Remember that? I know. I'm asking you to remember a lot of Chem 1A right now. So if you remember Lewis structure for H2O, this was a Lewis structure. So far so good? Okay. So HCl, Chem 1A again, H plus and Cl minus, it be treated like an ionic compound, right? HCl, and H2O is a covalent compound, so I drew a Lewis structure for it. Okay. Now, HCl is my acid, is going to lose H plus. Water is my base, is going to get an H plus. And you can probably see that. What did we say? We said before base can go and get an H plus, it needs to be able to afford it, right? Well, water has lone pair, has extra electron to go and be able to grab an H plus. So these lone pairs are going to go and are going to grab the H plus. Okay? So when that happens, then Cl minus is going to be by itself. And then here, the oxygen had 2 hydrogen, but it just grabbed another H. So now it's going to have 3 hydrogen. Now we use one of the lone pair to go and grab the hydrogen and make a bond, but there is another lone pair left. I'm going to put it on top of that. So far so good? Okay. Now, if you remember the 4 mole charges, so from before, this is going to be a plus charge. Now, why is it going to be a plus charge? Remember this. Here, this was neutral, right? but it gave up electron. So now is electron deficient. So when you go, after you adopt the property, now you're poor, right? So you're electron deficient now. You guys follow that? I want to mention it one more time. So here, water is neutral, but it gave up the lone pair to go and bond with hydrogen, to grab the hydrogen. So now is electron deficient. I'm going to put a plus charge on there. So far so good. Now the other thing I want you to pay attention to is that on this side, the charges, the overall charge is neutral. And on this side, plus minus cancel each other out, the overall charge is also neutral. We're good so far? Okay. Now, here's what I want you to remember, okay? Well, before we do that, I actually want to go over this. What's the name for that? What's the name for that? What do you guys, you might have had it. H3O plus, H3O plus. The name is hydronium. Hydronium. I want you to remember that. I want you to remember the name hydronium, okay? I want you to remember the name hydronium. So H3O plus is hydronium because you're going to hear that all the time. So far so good? Okay. Now, let's do a practice problem, yes? Yeah, let's do another problem to make sure that you guys are getting this down. So, let's practice again. What happens to acid? Acid is going to lose the H and base is going to get a H plus, right? Acid is going to lose it and base is going to get the H. Okay. Now, let's do another fairly easy problem. What I'm going to do, I'm going to have HNO3 plus water. Okay, can you write the other side for me? So, when you do this, again, pause me to do this and I'm going to go over them together. You gotta go, nitric acid is my acid. So if this is my acid, that means water is my base. And then you're gonna tell yourself, like, okay, Dr.E told me this so many times that acid is going to lose an H plus and base is going to gain an H plus. So if acid loses an H plus, it's going to be NO3 minus, and if the base gets the H plus, it's going to be hydronium, H3O plus. Now, this is a neutral on this side, all the charges. If you add up all the charges, it's also neutral. Now, I need you to remember from back in the days. When we had this in Chem 1A, if you remember, when you broke up the HNO3, it would be H plus NO3 minus. Now, here's what I want you to remember that, and I'm going to come back to this in a second too. That every time you have an H plus around, water is going to go and grab it and forms hydronium. Okay? So I'm going to repeat this again. Every time you have an H plus floating around, water is going to go grab the H plus immediately and form hydronium. So technically you can never have H plus by itself walking around in water. The water will grab it and it will form hydronium. Like for example here, nitric acid is H plus and NO3 minus. Every time you have an H plus, water is going to go grab the H plus and it's going to form hydronium. Okay, are we good so far? Okay, so I need you to remember that. And a lot of time, people write H plus, but every time they write H plus, what they really mean hydronium. Because H plus is not going to be lasting long in water. Water is going to grab it and form hydronium. I'm going to mention this again because it's going to come back later. Just want to make sure you understand it now. So every time you have H plus running around in water, that's not going to happen. Water will grab that H plus so quickly. So when we write H plus, what we really mean is hydronium, because water will grab that H plus pretty quickly and form hydronium. And we write both way, and that's okay, but just I want you to know the right way, which is hydronium. Okay, now I'm going to give you a hard problem to do. You ready? So let's do a hard problem. H2O plus HS minus. Pause me, do this one. I want you to write the product for this reaction. Figure out what's an acid, what's a base, and then figure out and then write down the product for this. H2O plus HS minus. You ready? Okay. So what's my acid and what's my base? Remember what we said. We said, so you know that water could act as either one, right? Okay. So it wouldn't matter what this one is. If this is an acid, water will be the base. If this is a base, water will be an acid. Water is easy going. HS minus, what is that going to act like? Remember what we said? We said that in order to be a base, you need to have extra electron. You guys remember that? You need to have extra electron in order to be a base because you need the extra electron to be able to afford the H plus. Does HS minus has extra electron? It sure does, because what does minus means? Minus means you have extra electron. Minus means you have too much electron, right? So HS minus can definitely act like a base because it has extra electron to donate, right? So it has extra electron to go and grab the H plus. So if this is my base, that means water is going to be my acid. Okay. Now, what did we say? Acid is going to lose a hydrogen, base is going to get a hydrogen. And this is my base because it has a minus charge. And we said that's what a base means. Base needs to have extra electron, has a lone pair or minus charge, some extra electron to be able to go and afford to getting a H plus. Okay, so this is a base, which means the water has to be the acid, right? Water is depending on the situation. Now, so water is going to lose a hydrogen. If water loses a hydrogen, it's going to become what? It's going to become OH minus. Because now you lost the hydrogen, now you have extra electron. Now, HS minus is going to gain an electron, so it's going to become, gain a hydrogen, is going to become H2S. You guys follow that? So water is going to lose the H plus, so it's become OH minus. It lost an H. Now remember, when you lose the H, so now you have more electron for yourself, right? Because you have one less atom and you have more electron. So it has a minus charge. Now H2S, HS minus, use the extra electron to get a hydrogen. Now is H2S. Now is a neutral charge because it used the extra electron to grab another H. We're good so far? Okay. The charges was hard for me when I was undergrad. That's what I'm emphasizing on that, to make sure that you guys are getting the charges down. Now, the other way to kind of look at it is that if you look at it on the left side, what is the overall charge on this side? -1. What is the overall charge over here? -1. There should be a conservation of charges, right? The charges have to match on both sides. All right, so before I go to the next part, let's review this again. How do you know you have an acid and base? The one when acid is going to lose a H plus and base is going to get an H plus. Acid is going to lose a H plus, base is going to get an H plus. And you are a base if you have extra electron to be able to afford getting that H plus. And water can act like an acid or base depending on the situation, right? If you have an acid, then the water will act like a base. If you have a base, then water will act like an acid. Now, the next thing we're going to talk about, and again, hopefully this is a lot of it is review from Chem 1A, but I just want to go over it anyway. We're going to talk about a strong acid and a strong base. Okay? Let's talk about a strong acid first. So we're going to talk about strong acid and strong base. What does it mean to be in a strong acid? Okay? What does it mean? Strong acid, and you have it in Chem 1A, what that means is they have 100% ionization or dissociation. They ionize in water 100%. For example, if I have HCl in water has a 100% ionization. Now, what does ionization mean? Ionization is a fancy way of saying breaks up, right? It's a fancy way of saying break up. So next time you want to break up with someone and you don't want to use the word break up, you can say, let's ionize. It sounds so much better, right, than break up. Let's ionize. And if they have no idea what you're talking about and what ionization is, you should break up with them anyway. That means they don't know chemistry. Alright, so this is going to break up into H plus and Cl minus, right? So, strong acid, they have 100% ionization, 100% dissociation. They would completely break up in water. That's what we learned in Chem 1A. So, if I have, for example, if I have 100 hydrochloric acid molecules, every single molecule is going to break up into H plus and Cl minus. You following me so far? Okay. Now, this is okay. This is okay if you write this. But hey, you are fancy now, aren't you? You are fancy now. What is a better way of writing this? This is so Chem 1A. You know better than this. Remember, HCl is going to be in water, right? We say 100% dissociation in water, right? These are all in water. So if I have hydrochloric acid in water, I know hydrochloric acid is my acid, and you know that water is going to act like a base. So I have acid, water is going to act like a base. Acid is going to lose a hydrogen, is going to become Cl minus. Water is going to gain a hydrogen, is going to become H3O plus. I'm not being consistent. Sometimes I circle my charges, sometimes I don't. I'm not trying to prove a point with that. Maybe I should just circle all of them. Alright, so far so good? So this is what you learn in Chem 1A, that strong acid will completely break up into ions, into H plus and Cl minus. And this is okay, but you are like on the next level right now. So this is my acid. You know that if hydrochloric acid is your acid, water is going to act like a base. So water is going to get a H plus, HCl is going to lose an H plus. Now this is fancy, this is cool. This is fancy, this is okay, but this is fancy. And this is a better way of writing it, because remember what we talked about. We said that H plus would never survive by itself, right? Water would grab it and form a hydronium. So H plus technically could never really be by itself. Every time H plus is hanging around, water is going to get the H plus and form hydronium. Are we good so far? And again, you see both ways. And sometimes I write H plus, sometimes I write H3O plus. They're the same thing. They are the same thing. People usually use them interchangeably. I do want you to realize that. So every time you see an H plus in this chapter, is probably the better way of writing it is H3O plus hydronium. So far so good? Okay. So strong acid, what they're going to do, they're going to have 100% dissociation. They're going to completely and fully break up in water. Now, when you break up, what you have an hydronium or H plus. Remember, this is what's responsible for acid being an acid. The H plus, the hydronium is what's responsible for acid to be an acid. When you have acidic food, they taste like sour, right? What is responsible for that? H plus or hydronium, that's what's responsible for that. So we really, really care about the concentration of H plus. Now, what do we care about? We care about it because, for example, if there's a lake and the lake has a high concentration of H plus, the fishes are going to die, right? Because we care about that in our water. We care about H plus because your blood has an H plus concentration. Did you guys know that? And the concentration of H plus in your blood is 4.0 times 10 to the minus 8. I have to read that. Now, if So the concentration H plus in your blood is 4.0 times 10 to the minus 8. If that concentration changes, what happens to you? You die, right? So we care about the H plus concentration. The acidic food that you eat, they have H plus concentration. That's what makes it to taste sour. So we care about H plus concentration. Remember that. So far, so good? Okay. Now, so strong acid, they will completely break up in water into H plus, or a better way to write a hydronium. How would you know if you have a strong acid? How would you know? You could always taste it, right? If it tastes really sour, it's going to be a strong acid. That was a joke. Do not try this. Another way, a better way to know if you have a strong acid is memorizing the 6 strong acids. HCl, HI, HBr, HNO3, HClO4, H2SO4. These are the strong acids. Everything else is considered weak. These are the strong acids. Everything else is considered weak. Okay? These are the ones that I'm going to consider in this class as a strong acid. Everything else is going to be considered weak. Again, what does it mean to be a strong acid? You completely and 100% would break up into ions, right? So if I had 200 hydrochloric acid molecules, every single 200 would break up into the ions. So far, so good. And then also, don't forget that we write H plus sometimes, but what we really mean is H3O plus. Just keep that in mind, that H plus by itself is not going to survive because water is going to grab that H plus and form hydronium. So that's a fancier way of writing things and doing things. We're good? Okay, so that was the strong acids. Okay, and again, I need you to know the strong acid. These are the strong acid and everything else is considered weak. Now, let's go to base. How do you know if you have a strong base? So next time you have food that tastes really sour, what are you going to be thinking about? You're going to be thinking about, oh, this is an acidic food. I wonder what's the concentration of hydronium in there. You will definitely think of that. Strong base. Strong base, the same thing, right? You're going to 100% break up into ions, right? The same thing as before. Now, how do you know if you have a strong base? How do you know if you have a strong base? Here's how you would know you have a strong base. You have to think about solubility, right? So again, a strong base is going to have 100% dissociation in water. It's going to ionize in water. It's going to break up completely in water. The same as acid. Now, how do you know if you have a strong base? Here's how you would know if you have a strong base. You actually have to look at the solubility rule, okay? Group 1A and bottom of 2A. So group 1A and bottom of 2A, okay? And if you have a periodic table, that would be SRBA and RA. Okay? If you have those next to an OH, those are considered strong bases. Okay? For example, NaOH. If I have an NaOH, Na is a metal, is a 1A group, right? Do you agree? Na is 1A group. Okay? So that's a strong base. So it will break up into Na plus and OH minus. Okay? So again, strong acid, you will have to remember those 6 strong acid, everything else is considered weak. A strong base, when you have OH next to group 1A metal or bottom of 2A metal, SRBA or RA, that would be considered strong base, and that means they are going to have 100% dissociation. Okay? Let's do another one. What do you think? KOH. Yeah? Strong base or weak base? KOH, K is from a 1A group on a periodic table, right? So if you have OH next to the 1A group on a periodic table, or the bottom of 2A, which is SRBA or RA, those will be considered strong bases, and they would completely break up in water. You guys follow that? Yeah? Okay. Now, yeah? Okay. Beautiful. Now I want to go over weak. Now I want to go over weak acid and bases. So hopefully you got the strong base and that strong acid done with 100% dissociation. So if you have any metal, 1A group metal or bottom of 2A metal next to the OH, those are considered strong bases. And the same thing as acid, they're going to 100% break up into ions. Now let's talk about weak acid and bases. Okay? Now what does it mean to have weak acid and base? The same thing as before. You have this in Chem 1A. So strong acid and base, it will 100% completely break up in water, right? So strong acid or base, it will completely break up in water, every single molecule. Now if you have weak acid or base, they will partially dissociate in water. Not all of them will break up, some of them will. Okay? So dissociate only, slightly dissociate, and so partial dissociation. Partially dissociate in water. So they will partially dissociate in water. So far so good? Okay. Now, we're going to do a couple of practice. NH3 plus water. Pay attention to this one. This one is the important one. NH3 plus water. What is NH3? I'm hoping you remember this. NH3 is ammonia. Okay. NH3 is ammonia. Now, ammonia is a weak base. Now, ammonia is one of the ones that we ask you to kind of memorize it in Chem 1A. It doesn't have an OH, but it's a weak base. And you're about to see why it's a weak base. So, ammonia is a weak base. I need you to remember that. Okay? Make a note of that. That ammonia, NH3, is a weak base. It doesn't have an OH, I know, but it's a weak base. So, if ammonia is my weak base, what does that say about water? That means water is going to be my acid. That means water is going to be my acid, okay? So ammonia is my weak base. That means water is going to be my acid. Now remember what we talked about. We said that acid is going to lose the H plus and base is going to get a H plus. You agree? So ammonia is going to get a H plus. It's going to become NH4 plus. It was neutral here, but it got an H plus. Now it doesn't have enough electron. Now it becomes NH4 plus. Now water is going to lose the H plus, so it's going to become OH minus. So ammonia is a weak base. I need to remember that. So if I add ammonia to water, since ammonia is my base, water is going to act like an acid. We talked about it. Base is going to get an H plus. Acid is going to lose an H plus. We did that, and this is our product. Neutral on this side, plus minus, neutral on that side. Okay. Now, here's interesting. So, ammonia, it doesn't have an OH, and you may have been confusing Chem 1A. Why does it act like a base? Now you know, because when you have ammonia in water, what does it form? It forms OH, which is a base, right? So, usually in Chem 1A, we have a hard time explaining why ammonia is a base when it doesn't have an OH. Now you know that when it adds to water, it does an acid-base reaction, and you form an OH minus. You form an OH minus, so it's a base. So far so good? Okay, let's do one more. Let's do one more. Okay, so next one I want to do is HC2H3O2 plus water. What is this one? HC2H3O2. What is that? That is acetic acid. Remember the formula. This is acetic acid. Acetic acid. Is it a weak acid, a strong acid? What is going on? It's a weak acid. It's not on the list, right? It's not on the list. So it's a weak acid. So if this is my acid, that means water is going to be my base. That means water is going to be my base. You guys are good so far? So if this is my acid, water is going to be my base. Okay? So the acid is going to lose the H plus. Water is going to get the H plus. Acid is going to lose the H plus. Water is going to get the H plus. So here is going to lose that. So I'm going to have acetate left. And this one is going to get the H plus, so I'm going to have hydronium, right? You're going to get the H, now you're electron deficient. Okay, H plus, this is acetate. You lost the H plus, now you have acetate left. We're good so far. Neutral, neutral on both sides. Okay. Now, let's go over this one more time. So, strong acid or base. You know you have a strong acid or base. So, strong acid, you have the 6 strong acid. HCl, HBr, HNO3, H2, SO4, HNO3, and HClO4. Memorize those. Clearly, I didn't have memorized them that well. Memorize them, those are the strong acid. Everything else is considered weak. Acetic acid is not on there, it's considered weak. Okay? For bases, if you have an OH next to 1A group metal or bottom of 2A group metals, you have a strong base. Strong acid or base, they will completely and 100% break up in water. Now, for weak acid or base, and ammonia is a weak base, I need you to remember that. Ammonia is a weak base. They would only partially break up in water. They would not fully break up in water, right? This is what it means to be a weak acid or base. So here, for example, if I have 100 acetic acid molecules, probably 95 of them are going to stay together. Maybe 5 of them are going to break up, okay? So what that means is I don't have as many H+. I don't have as many hydronium, so it's a weak acid, right? Now this is interesting because what is acetic acid? Acetic acid is vinegar, right? You've tasted vinegar. What does it taste like? Sour. So even though acetic acid is a weak acid, which means not every single acetic acid molecule would break up. Probably 95 would stay together, only 5 of them, only a few would break up into ions. But that 5 molecules that broke up was enough to give you the sour taste, right? But you have less of hydronium, and that's why you are a weak acid. We good so far? Okay, yeah, weak acid, you're gonna have less of that. Now, because when you have weak acid or base, not everything would dissociate. What you end up having, you're gonna end up having an equilibrium, right? So when you have a weak acid or bases, what you have, you end up having an equilibrium. So what we have to do, we have to draw equilibrium error. There's a forward and there's a backward reaction. So every time you have a weak acid or base, you are going to have an equilibrium. So every time you have a weak acid or base, you are going to have an equilibrium. Yeah? Okay. You know equilibrium well. Now let's do one more practice problem. And I'll show you the next part of that practice problem. Good job hanging in there. This is a fun chapter. I think it's fun. So, hydrofluoric acid. Write down hydrofluoric acid. Let's remember if you remember your naming from Chem 1A. Hydrofluoric acid. Now, hydrofluoric acid, is it a strong acid or weak acid? What do you think? Strong acid or weak acid? Hydrofluoric acid is a weak acid. It's not on the list of the strong acid that I gave you, right? So it's a weak acid. Okay, so it's a weak acid. Now, you guys want to hear something interesting that always bugs me? So, hydrofluoric acid is a weak acid, right? Here's what's very interesting. The strong acid, hydrochloric acid, iodic acid, nitric acid, sulfuric acid, they can't really kill you. If you get it on you, it's going to sting. It may leave a scar, but they're not going to kill you. You'll be fine. Hydrofluoric acid is a weak acid, but if you get hydrofluoric acid on you, you'll be dead very soon. Now, why is that? Now, I can almost like see your faces like, oh my God. Don't worry. No university is going to have hydrofluoric acid on campus. But why is that? A weak acid is going to kill you. Here's why. If you get hydrofluoric acid on you, you won't even feel it because it's a weak acid. It's not going to have that many H pluses. But fluoride loves calcium. Your bones are made from calcium. So it gets your bone and it starts eating your bone. And then painful death. But okay, this is not how I wanted the lecture to go. But the good thing is, you're probably never going to encounter hydrofluoric acid in a chemistry lab. So, but the interesting part was like the weak one can kill you, but not the strong one. So, hydrofluoric acid is a weak acid, right? It's not one of the strong acid. And then if I add it to water, okay, if I add it to water, so that means this is my weak acid. That means the water has to be what? The water has to be a base. Now, because I'm talking about a weak acid, what am I going to do? I'm going to have a double arrow. I'm going to have a double arrow. You're going to have an equilibrium every time you have a weak acid or base. Acid is going to lose a H plus. Base is going to get an H plus. So I'm going to have an F minus plus hydronium. F minus plus hydronium. Are we good so far? Okay. Now, because this is an equilibrium and you are going to have an equilibrium every time you have a weak acid or base, what do you need? What do we need? We need an equilibrium constant, don't we? So, we need an equilibrium constant. So, because this is an equilibrium, right? And every time you have a weak acid or base, you are going to have an equilibrium. It's a forward and backward reaction. You're going to need an equilibrium constant. You're going to need an equilibrium constant. We're good so far? Okay. And the equilibrium constant is the same as before. It's product over reactant. Product over reactant. So, we are going to write an equilibrium constant for this, okay? We're going to write an equilibrium constant for this. K for the equilibrium constant, okay? Equilibrium constant was what? Concentration of the product over concentration of the reactant. Do you remember that? Okay. So it would be concentration of F minus times concentration of hydronium over concentration of HF. And if you remember, we said we do not include liquids or solid in the equilibrium equation. So I do not include water in there because we said we can't say our water is too concentrated, right? It has a constant concentration. Okay, so product over reactant. Nothing you've never seen before. So every time you have a weak acid or base, you are going to have equilibrium, a double arrow. Every time you have an equilibrium, you have to write an equilibrium constant. Equilibrium constant, product over reactant. That's what we did over here. That's what we did over here. Nothing you hadn't seen before. Now, this is where it gets really cute. What do we call this equilibrium constant? We call it Ka. What is the A for? A for acid. A for acid. So if you had a base, it would be K, it would be Kb. If you had a base, it would be Kb. So far, so good. So if you had a base, it would be a Kb. Yeah? Okay. Now, last thing. Let's just do a quick practice problem and then we're done. One thing I do want you to kind of realize though, remember, when you have a weak acid, you don't form as much hydronium because not every single acid is going to break up. So you have less of this, and that's why it's a weak acid, because the H plus is what makes something to be acidic. You ready? Okay. So here is our practice problem. Here is our practice problem. I'm going to write down 3 weak acids, and I want to ask you which one do you think is the weakest one? I don't know all weak acid, but which one is the weakest one? H3PO4, and I'm going to give you the Ka value for all of them. Has a Ka of 7.5 times 10 to the minus 3. Hydrofluoric acid has a Ka of 7.2 times 10 to the minus 4. And carbonic acid, or soda, has a Ka of 4.3 times 10 to the minus 7. Okay, I need you to tell me this. You can't tell me, you can tell someone around you, your roommate, your siblings, anyone you can find. You can tell me too. These are all weak acid. Phosphoric acid, hydrofluoric acid, and carbonic acid, weak acid. But which one is the weakest one? Which one is going to act like the weakest acid among these 3? Remember, the weak acid have equilibrium, backward and forward, and they have an equilibrium constant. So the key is look at the equilibrium constant. Now, here's something to is good for testing. If you take a test in any subject, test taking skill. When they ask you what is the weakest or what's the strongest, don't ever pick the middle guy, right? You pick the smallest number or you pick the largest number. Don't pick the middle guy. You won't take it personal, okay? So when I look over here, I'm either going to pick the smallest number or the largest number, okay? Now, which one? Ask you which one is the weakest acid. What does Ka mean? Now, remember what we talked about. Ka is product over reactant. Do you agree? So, Ka is product over reactant. Now, so Ka, hopefully you can see, Ka is product over reactant. The product has a hydronium concentration and the reactant has some sort of acid. I'm just going to put HX and X here. Doesn't matter what X is. Okay? So Ka is basically the product over reactant, and then the product is going to be hydronium or H plus over the acid. So the larger the Ka, what does that mean about the hydronium concentration? You have a larger concentration of hydronium. You guys follow that? Let me repeat it one more time. So remember, Ka is product over reactant. My product is hydronium. So the larger the Ka means I have more hydronium. More hydronium, remember hydronium, the H plus, that's what makes something to be an acid, right? So the more hydronium you have, the stronger you are going to be, right? So more hydronium, that means you're going to be a stronger acid. And more hydronium means you're going to have larger Ka. So which one, A, B, C, do you think is the weakest acid? The weakest acid is going to be C. This is going to be my weakest acid. Why is this going to be my weakest acid? Because it has the smallest equilibrium constant. Because it has a smaller equilibrium constant. So I'm going to write this down one more time. What this means the higher the Ka, more acidic you are, stronger you are. So higher the Ka, that means you are a stronger acid. Okay, more acidic you are. Because a higher Ka means you had more hydronium. Because K, equilibrium, is product over reactant. The higher Ka means you had more hydronium. You have more hydronium, you act more like an acid. Because H plus is what makes something to be an acid. So far so good? Okay, so here's the take home points. Remember, every time you see a weak acid or weak base, they're going to have an equilibrium. Every time you have an equilibrium, you're going to have an equilibrium constant. Ka, Kb, again, is product over reactant. And remember, the larger, the more hydronium you have, that means you're going to have a higher Ka value. That means you're going to act like a stronger acid. Okay, long one. Thanks for hanging in there. I'll see you guys next time.